Good morning. Thanks for stopping by. Today, we are going to talk about how it is we establish something as being true or not true. How do we organize an argument that something has to be the case? So, when we make a claim, claims are supported by evidence, and we're going to look at a way of organizing evidence to support a claim, and it's called a flowchart proof, and it's visual. It involves drawing some ovals, or you could use rectangles or something too. But that's what we're going to look at this morning with a couple examples, and I'm also going to talk about a couple notation things regarding diagrams. So yesterday and the day before, we settled in on two triangle congruence conditions. We call them angle, angle, and then the side, or angle, side, angle, or two angles and the side that's included or in between them being congruent. When we see that pattern in a diagram, we have enough evidence that the triangles are congruent that we're calling those a triangle congruence condition. So what we're going to do today is look at a couple triangles and decide if the triangles we're looking at meet those conditions, either one of them. And if the triangles meet the condition, then how do we organize an argument that the triangle is congruent? Now, I want to caution you because sometimes we make the mistake of thinking that this is super simple and it's obvious. But I want you to slow down and think about this. Organizing evidence to support a conclusion is never simple. It's never simple when it really matters. So it's good to think about how you do that in a non-controversial setting, so that when you do have to perhaps make an argument to support a conclusion, you can do it in kind of a methodical way and make sure you've got your facts straight. So let's start by looking at these two triangles, and I'm just going to quickly kind of annotate things that I see. I see that I've got this 75-degree angle, and this triangle has a 75-degree angle, and then there's this 32-degree angle and a 32-degree angle. And then down along the bottom here, I've got this side length that's 5.75, 5.75. And when I look at this, I can see that I'm clearly meeting the angle, angle, and then the side, right? Angle, angle, and then the side. So these two triangles are congruent because of angle, angle, side, because of the angle, angle, side congruence condition. So how do I organize that? Well, in order for two triangles to be congruent because of the angle, angle, side congruence condition, three things have to be true. You have to have two pairs of corresponding angles being congruent, and then the same corresponding non included side being congruent. So because I know three things have to be true, I'm going to start this proof, and I'm going to try using some colors here. I'm going to start this proof by pointing out that I'm going to do a pair of angles, and then I'm going to do another pair of angles, and then I'm going to finish up with a pair of sides. And when I get all of those things in that order, right, then that supports the conclusion I'm making, right? Namely, the conclusion I'm making is that these two triangles are congruent. So sometimes I like to think about what my conclusion is. I mean, right now, I've verified that I have enough evidence to make this claim, but sometimes I like to write down my conclusion and then back up over that evidence that I've already organized. And even though I say that, you can see I'm already thinking kind of both forwards and backwards about how this works. So in the end, I want to say something along the lines that triangle CBA, let's see, triangle CBA, I want to say that triangle CBA is congruent to triangle OPT. OPT. And you'll notice as I'm doing this, right, angle B and angle P are both the 75-degree angles. Angle A and angle T are both the 32-degree angles. And angle C and O are congruent also, right, because they have to add it to 180 degrees. So when I write these down in this order, there's other orders I could have used. I could have used triangle ABC, but when I do that, I would have to write the corresponding order for the matching triangle. Now, I believe these triangles are congruent, and I think it's a pretty fair, safe assertion because of the following items, right? I know that angle B is congruent to angle P, right? I know they're congruent to each other because they fit the definition of congruent triangles. Right? The definition of congruent triangles say two triangles are congruent if they have the same number of degrees. These two both have 75 degrees, therefore they're congruent to each other. The other thing that I have is that angle T is congruent to angle A, and I'll probably write it in the other order. I'll say angle A is congruent to angle T. And again, same reason, right? The reason those are congruent is because I'm given that they're equal in measurement, therefore they have to be congruent. And then the final thing I'll write down here is I'm going to say that segment AC is congruent to segment TO. And I can see that both of them measure 5.75 centimeters, so they're congruent to each other. So in this kind of maybe even oversimplified or a bit simplified proof, the reasons why I can make these claims are that I have angle measurements that are given. So what we do is when we have an oval like this, we have to have a reason that supports it. And the reason here is that this is given information, right? I'm just reading from the diagram that those two angles had the same measurement. Same thing here. This is given information. They both had the same measurement. And finally, for the segments, this was given information. So I want you to see this pattern, right? A flowchart proof has these ovals or some kind of circular shape or something, or squares. It has a statement that you're making, and the reason that that statement is true is off on the left-hand side. Now, all three of these statements flow. That's why it's called a flowchart proof. They flow into this statement. And if you look, what I've just provided this statement of congruence with are exactly the two pairs of congruent angles. There's one pair, there's another pair, and then the non-included, or the side that's not in between but still corresponding segment length. So these triangles are congruent because of the angle side congruence condition. That congruence condition is met in this triangle, and if we kind of just look at the whole thing, it seems pretty straightforward. I say that, but I know that it's going to take a bit, and some of they're going to grow in complexity, especially over the course of the next 2 years. But let's just take a look at this and make sure we understand that these two triangles meet the AAS congruence condition, therefore they're congruent to each other. And this concluding statement that I've made, right, is supported by the evidence above. And not only is the evidence flowing into that argument, but you can see that I'm including arrows showing the direction, right? The given statements are going into the statement that requires the two congruent angles and the congruent segment or side. So I want to point out that in this diagram, we were actually not given that these angles and the side lengths were congruent. We were given that they were equal in measure. right? What we were given that angle A and angle T were both 32 degrees. Then we can say because they both are 32, they are congruent to each other, because for an angle, and it's pretty simple for both angles and segments, for an angle, two angles are congruent if they have the same number of degrees. That's the definition of a congruent angle. Same thing with the segment. Two segments are congruent if they are the same length. That's the definition of a congruent segment. What does it take for a segment to be congruent? I point that out because I want to show you how we would note that things are congruent in a diagram without actually knowing their lengths or the number of degrees they contain. So if you look at the markings that we have here for these two angles, right, this angle and this angle, we know that those angles are congruent to each other because they have the exact same arc and a single tick mark on it, right? So those angles are congruent, and that's actually given information. It is given that those two angles are congruent to each other. Similarly, these two different side segments, for example, this particular side and this side, those two side lengths are congruent because of the tick marks we see. And same thing with the other thing. So the other thing that's shown on this is whenever we see this square symbol in an angle, right, we know that these are 90-degree angles. Well, if they're 90-degree angles, right, then they contain 90 degrees, and because they both contain 90 degrees, they're congruent to each other. Okay, it's a very subtle path, but it's important that we understand that sometimes these things don't necessarily flow. So that's why we take the time to point them out. So let's take a look at our second proof. For this diagram, it's to me pretty clear that there's enough evidence that the triangles are congruent. The problem is we've got to pick a strategy and decide what we're going to go with. So just to give you a for instance, I could use the two angles in triangle PIG. I could use these two angles to make an argument about how big angle G was. And I did the arithmetic, and it turns out that angle G is 101.2 degrees also. So I could make that argument, point out, oh, angle G is 101.2. And that argument would look something like, hey, angle I is 22.3, angle P is 56.5, angle P, I, and G are the three angles in a triangle. So then I could say, oh, therefore angle G has to be 101.2 because of the triangle angle sum theorem, which just basically states the triangle angle sum theorem says if you've got three angles in a triangle, they have to add up to 180. And since we already know the two, right, clearly G has to be 101.2. Now that I've established that angle G is 101.2, I could take it a step further and say, hey, because angle A and angle G are both 101.2, and I would have to say angle A is 101.2. That's given. But now that I have the A and G are both 101.2, I could then say, hey, angle A is congruent to angle G. And then from there, I could get to a point where I would be looking at angle side angle. So let's take a look at the book because they give us a structure that we're going to use to complete a proof for this. Okay, so this is the layout for the proof that they've given us here, and I guess I'm going to look at this. You can look at it top down. We are going to get to where we're saying these two triangles are congruent by angle side angle. So what we were talking about is relevant. And the first thing that's happening here in the given is mostly we're just stating what the measurements of the angles are. And I want to say that down here that angle C and P are congruent. So in order for me to say that, I have to show that angles C and P have the same number of degrees. Well, it turns out angle C is 56.5 degrees and angle P is as well. And I can see that that's given in the diagram. So I'll say right here that the measurement of angle P is 56.5 degrees. And that's given from the diagram. Now that those are both 56.5 degrees, I can say, well, if this is 56.5 degrees, let me turn off this. If this is 56.5 degrees, right, and angle P is 56.5 degrees, those two angles must be congruent to each other because they fit the definition of congruent angles, right? Two angles are congruent if they have the same number of degrees. Something similar is happening with the side lengths, right? They're talking about segment CA equals 12 and segment PG is also equal to 12 units. So now I can flip from talking about the lengths of the segments to the segments themselves. So a bit of notation, by the way, when you see M angle P, that's how I talk about how many degrees it have. So a statement like that, the measurement of angle P would always have a number of degrees. If I just talk about angle P like I am here, I'm not talking about its measurements, but I'm talking about an attribute that it has. Angle P is congruent to angle C. That's the attribute. And I can also talk about an angle's rotation, right? So an angle's vertex could be pointing a certain direction. So angles can have more than one attribute. So let's talk about this. So now since these two segments are equal in length, now I can talk about the segments being congruent. So the notation flip would be, instead of just CA, I'd say CA with a line over it. So now I'm talking about segment CA, right? This is read the length of segment CA, and this is just segment CA is congruent to segment PG. Segment PG. So when I write the line over it, I read that the segment, and up here I'm talking about the length of it. And again, in order for these two segments to be congruent, it has to be the case that they are equal in length, and I can see that I've supported evidence that they are equal in length. The evidence is that it was given in the diagram in both cases. In fact, I should write the word given here. So in both cases, it was given that they were equal in length. Therefore, they are congruent to each other. And then the last thing over here is this angle business. So one of them is given, right? And in fact, it's angle A. So I can say the measure of angle A, I'm looking at the diagram right up here, right? The measure of angle A is 101.2. So I'll say that. I'll say the measurement of angle A is 101.2 degrees. So now that I see that those two angles are equal to each other in terms of the number of degrees, right? Now, I want to point this out. In the diagram, they did not give me that angle G was 101.2. That wasn't given, right? What I was given was the other two angles. And the claim is that if I take 180 and I subtract the 22.3 and I subtract the 56.5, that will equal 101.2. So you can see my argument here is not that I was given anything about angle G. I was given information about two other angles. So therefore, because of that, the angle G has to be 101.2 because of the triangle angle sum theorem, which again, from a few sections ago, just states that the two angles in a triangle are always congruent, or the three angles in a triangle rather always add up to 180 degrees. All right, so when I finish this, I do have at this point all the things required for angle side angle. I've got the 56 degree angle, and I've got the 56 degree angle. I've got the 101.2 degree angle in A, 101.2 in G. And also we have that these two segments are 12 units long. 12 units long. So you can see we clearly have angle, and the included side. So we can go ahead and say that these two triangles are congruent. And if I was to say, for example, I'm going to put down triangle CAT. So I'm going to say triangle CAT, and that is congruent to. Now I have to match up parts, right? So I know the angle C goes with angle P. So I'll say triangle P was the one that went here. For A, it went with G, right? Angle A went with angle G because those were the two that were 101.2. So if I have angle A listed second, I'm going to put a G here. And then the last one I do is going to be angle I. So I have angle CAT is congruent to, I'm sorry, triangle CAT is congruent to triangle PGI by angle side angle rather, and I just want to include these arrows to show that yes, I am providing it with the two angles and the side that connects in between them. Now it's convenient in this proof that I did put this side in the middle, so the segment in the middle, so you can see here that yeah, the segment was included in the middle statement and I needed that. That's not necessary. It is helpful for your readers if you organize your proofs like that, but it's definitely not necessary. And I just want to finish with a couple remarks about this. This diagram appears in the book and I modified it just slightly. But basically the thing is what's the difference between the two of them, right? How is the top diagram different from the bottom diagram? And it's just a matter of where we're starting and where we're going. So if you look at this top diagram, right, and I don't even see this top flowchart proof rather, I don't even see the diagram that goes with it. It appears that I have two triangles, triangle ACB and triangle RSQ, and I'm establishing that they're congruent to each other using angle side. So I'm providing that statement with the things it needs. It needs the angles, it needs the sides. In the diagram below, I'm being told that the triangles are congruent, right? It's already by some other means, somehow we're told, we're given the information that triangles are congruent. And if the triangles are congruent, then, right, then their corresponding parts are congruent. So down below, I'm starting with the congruent triangles and therefore I get congruent parts. Above, I'm showing an adequate number of parts are congruent to get congruent triangles. By the way, for this bottom diagram, I could say more too, right? For example, we could say just as well that we could say angle B is congruent to angle Q, right? There's a lot of things that we get from congruent triangles, right? Namely 6 things. So if we have congruent triangles, there's 6 things that are true. And sometimes it's the case that, you know, we might use 3 different sets of things to get the triangles are congruent, and then we use that to show one of their parts is congruent. So again, it's just a matter of what are we starting with and where are we going. That's the difference between these two diagrams. All right, so we're at a little less than 23 minutes. That's it for today. I hope you have fun doing your review preview assignment for today, and I look forward to seeing you in class on soon. A reminder for everyone watching that we are taking our Chapter 6 test this Thursday and Friday. I'll see you in room 309.